Now that we've introduced the problem statement and shown you the initial results, I'm going to walk you through in a little bit of detail exactly how we used Arthur Bench to generate those results. This is the landing page that you would see when you first launched Arthur Bench with a couple of test suites integrated. Each one of these test suites allows us to perform a comparison for a particular model against other models. You can see here that all of the Bedrock models, which were highlighted in the results, are represented as specific test suites. And the reason we decided to model it this way was specifically because, one, the training data or the data we use to do the evaluation has no labels. There's no gold standard reference summary that we could use to determine which summarizations were best. And similarly, we wanted to perform head-to-head model comparisons so that we could calculate the ELO rating. So if I wanted to dig in a level deeper, let's take a look at exactly how the Titan Text Lite V1 model compared against the other models. The first thing you see here is this distribution of these test runs. There are 4 different categories here. On the left is the reference category. This shows the number in this on these distributions shows the number or the percent of the cases where the scoring method preferred the Amazon Titan generated summary over the specific candidate model's generated summary. Similarly, the candidate distribution here shows where the specific candidate summary was preferred over the Amazon Titan's summary. And then we have 2 other cases here, equal, where equal is being the scoring method preferred either or both equally, and invalid, which is when there was an issue with the scoring method being able to calculate a result. We can also come down here and see an aggregate score, where a score of 0 means that every article, the scoring method preferred the reference or the Titan model, and a score of 1 being that the scorer preferred every instance of the candidate model. We could even go a level deeper here, so I'm going to select all of the different test runs and come over here and compare. This is going to show a table of each individual article and how the Amazon Titan model did the summary and all of the specific summaries from the Llama models and the Claude models. We can click in here into a view and get a high-level overview of what those exactly look like for this specific article. And again, we can see how the scorer, which summarization the scorer preferred, where a score of 0 here was the scorer preferred the Titan score. So you can see the scorer preferred Titan over both of the Llama models, or a score of 1, which is where the scorer preferred the candidate model. And in this case, you can see that the scoring algorithm preferred both of the Anthropic Claude models over the Titan model for this particular article. So now that I've demonstrated how we can use Bench to dig into these articles at a very specific level, I'm going to show you exactly how this was implemented. So first of all, this is an IPython notebook. You can use whatever Python interface is most comfortable. Any of your data scientists or machine learning engineers are going to be intimately familiar with this interface. This interface also makes it incredibly easy to just very quickly throw up some simple Python. And in this notebook, I was able to put this together in 30 minutes. We use no advanced APIs, no advanced functionality of the language, and there are very, very few dependencies here that need to be managed. The very first thing that we do here is set up the AWS Bedrock client. I took this directly from the AWS's documentation, and it took me 2 seconds to put this together, copy the code in here, and start generating inferences with Bedrock. Then we load our data, we prepare it for inferencing, and then we generate the inferences. You can see here that I am manually managing all of the prompting and the API interactions with the Bedrock models themselves. I'm not using a dependency like LangChain to do this. This was incredibly simple for me to put together and start rapidly prototyping based off of the documentation I pulled from AWS's website. So we generate summaries for Llama, for Titan, and for Claude. And then we define our models here, and we actually go through and run the inferences. Once we've generated and run all of the inferences, then we start interacting with Bench to set up the test suites and run the specific test runs for that suite. You can see here generating a test suite is a couple of lines of Python. We basically define a test suite, which again is a holder for a comparison between a reference model and candidate models. And then for each of the candidate models for a particular suite, we run that specific candidate comparison. Finally, taking the outputs from Bench, we're able to, because these are head-to-head comparisons, determine for each individual inference for each combination of models, determine which model was a winner here, and that by this we mean which summarization, the scoring algorithm preferred, or in the event of the draw, we can call it a draw where they were equally preferred. And then finally, we're basically able to take all of this and compute the ELO scores, which are represented here. At a very high level, what we've done here is demonstrating how quickly and easily it is to get up and running with Bench, to use it for enabling your machine learning engineers and your data scientists to very quickly compute relevant metrics that are very task specific for the problem at which you are trying to leverage large language models to solve. Thanks for the time.